by trigonometric transformation. But this time, we're going to finish the last two cases, and these are cases 5 and 6. Case 5 is actually same integral form for case 4. The only difference that of the condition, of course. So we have case 5. If the integral has the form integral of make nice one tangent to the m of u secant to the n of u du, or this combination of product of powers integral of, let's say, cotangent to the n to the mu cosecant to the nu du where we're going to place this time the condition to m, not anymore to n. In case 4, the condition was placed in n, okay, or on n. No? This time we're going to place our condition on n. So where m is a positive odd integer greater than or equal to 3. So meaning your m can be 3, 5, 7, 9, and so on. N can be any. Is that clear, guys? You can have n even, you can have n odd, you can have n fractions, whatever. Okay? Now, of course, if n happens to be 0, so this case reduces to our case number 3. Okay, guys? So, actually, as I said, case number 3 is special case actually and of case 4 and 5, depending on the exponent of m, or n if you are considering case 3. Now, if let's say m is odd and n is even, so meaning they both satisfy cases 4 and 5. So you can choose any of that case, okay? So you can consider case 4, you can consider it case 5. If case 4, you transform coming from this secant to the n. And if case 5, you transform coming from what? From tangent to the m. But if you are wise, of course, so you have to choose the smaller exponent. If you think m is bigger than or larger than n, you consider it, and m is odd, you consider it case 5. And let's say n that is even, m is odd, but n happens to be much larger than m, so you consider n, which is even, case 4. Is that clear, guys? So if this is the case, use the following identities to transform either one coming from tangent to the M or one coming from the cotangent to the M. Use the following identities. We have tangent, secant, which are we going to transform? Tangent, no, coming from the tangent to the M. So tangent squared u is equal to secant squared u minus 1. Or if coming from cotangent to the M, you transform the quadratic cotangent, so that is cotangent squared u into cosecant squared u minus 1. Okay? So you're going to get one tangent from tangent to the M, and then one secant actually from secant to the N, and that will serve as what? As the derivative of secant later. Now, together with du, the differential of secant. And then the remaining, which is in terms of tangent, so you form power of cotangent, that is actually quadratic power, and then replaced by its corresponding identity, either this one or this one, depending on whether quadratic power of tangent or quadratic power of cotangent. And so transform into any of this, and then expand if, of course, the exponent is more than 1. Okay? So let's do that in the following examples. If you have question, guys, you just raise your hand or you can interrupt me. Number 1, integral of tangent cubed of 3x secant to the 9th 3x dx. So here our m is what? Is 3. And that happens to be odd, greater than or equal to 3. So this integral satisfies this form. So we can use the transformation provided in case 5. Okay, guys? So this is what we're going to transform. Okay? So first, we're going to express tangent cube into quadratic power. So the remaining, one of tangent will be what? Will be associated with dx together with one secant coming from secant to the 9th. So we have tangent squared 3x, then times secant to the 8th 3x. We are going to separate one tangent from this tangent cube, no? And one secant from secant to the 9. So we have secant of 3x tangent of 3x dx. So this will serve later as the differential of secant. So all you have to do is, of course, fix in case there is a missing constant to complete the differential of secant. So this is retained now, this secant to the 8th, and then we are going to transform this quadratic tangent. Okay, guys? So transform in this form, secant squared minus 1. So this is equal to integral of, so that is secant squared of 3x minus 1 multiplied to secant to the 8 of 3x, then times secant of 3x tangent of 3x dx. Okay, guys? So this is equal to, well, let's distribute secant. Inside parentheses, we have the first term gives us secant to the 10th of 3x minus secant of 3x, and this secant is raised to 8. Okay? So each will give us general power formula. So each term will have a u of secant, and n from the first term, 10, from the second term, 8. Okay, guys? Do you have any question with that, guys? And so what is our u? Our u is what, guys? What is our u, guys?
3x po.
So our u is secant. Secant of 3x. And what's the du for each integral that we have? Because you can do it mentally, you can split it mentally, and this will serve as part of the differential. So what is the differential of u? So what is du, guys? So 3 secant of 3x tangent of 3x. Am I right, guys? Guys. Okay?
Yes po,
So
sir.
there is a missing 3 here. And actually, it is now a u, no? So we get what? We get integral of, this is u. If you want, you can transform it into u to the 10th minus u to the 8th. You can use substitution if you want, so that you can clearly see that it is u to the n du. And what is now secant 3x tangent 3x dx, guys? It is du over 3. Am I right, guys?
Yes, sir.
So I don't need 1/3. I can put it out and then integrate it term by term. So we have u to the 10th minus u to the 8th du. What is the integral now, guys? 1/3 times u to the 11th over 11 minus, I have to multiply also that by 1/3 times u to the 9th over 9 plus c, na? Of course, I have to put it back in terms of its original form. So u is originally secant, no? So 1 over 33, and that is secant of 3x, and this secant is raised to 11 minus 1 over 27 and secant of, so that is secant to the 9th of 3x, and then plus c. Okay, guys? That's it. Did you understand that, guys?
Yes, sir.
So you
Yes,
have
sir.
to master those cases and how to transform each case. Okay? How to do the transformation in every case. So you have to take note of what trigonometric powers are involved, and also the conditions placed either on m or n or to both. So let's have number 2. So let's say we're given this integral of cotangent to the, let's say, to the 5th of 2 theta, and then cosecant to the 12 of 2 theta d theta. Okay? Actually, if you're going to examine the exponent, this integral takes the form of case 4 or case 5. Am I correct, guys? If you consider it case 4, so that is because of what? Because of the exponent of secant that is even. If you consider it case 5, because of what? Because of exponent of cotangent that is odd. Is that clear, guys? But if you are going to compare their values, this is 5 and this is 12. 5 compared to 12 is what? Is smaller than 12, no? Am I correct, guys? So which one is easier to what? To expand after transformation? What do you think? Cotangent, quadratic cotangent, having later will have exponent of 2, or the cosecant that will have an exponent later of, actually you get cosecant squared, then there will be a remaining 10, and then you have to express that as quadratic power raised to 5. Oh, what do you think? Which one is easier to expand, having exponent of 2 or having exponent later of 5? Guys, Domingo. Guys, still alive, guys?
Yes, sir.
Oh, which one is better? Of course, no? So, considering it cosine, I mean, case 5. Am I right? Expansion of quadratic cotangent raised to 2. That is easier to expand. So, what you do, you transform this rather than the quadratic cosecant raised to 5 later, no? If you're going to uh, consider it case 4. So better to consider it case 5. Okay, guys? So we now have integral of quadratic. We have to form quadratic cotangent of 2 theta. And so raised to what? Raised to 2. So that gives us 4. And then we are going to get one cotangent and one cosecant from these powers respectively, no? So we have one cosecant of 2 theta, cotangent of 2 theta. And then there is a remaining what, guys? Remaining cosecant to the 11. Am I right, guys? So you have to multiply by cosecant to the 11. Okay? So let's move this to give space for that remaining. So we have cosecant. So we have cosecant what? To the 11 to theta. I think space is not enough. So we have 2 theta and then times this. Okay now guys, so check the exponent. 2 times 2, that is 4 plus 1, 5. And then 11 plus 1, 12. So this is what we're going to transform. This quadratic, transform it into what? Guys, what is the transformation, guys? Guys. Okay, parang I'm talking to the deaf and mute. Guys, cosecant squared 2 theta minus 1 raised to 2. Then, cosecant to the 11 of 2 theta is retained. And of course, we copy this differential in the future, no? Yan. Differential later. What future? Your future. Let's move to the next line. Expansion gives us cosecant to the fourth of 2 theta minus 2 cosecant squared 2 theta and then plus 1. Multiply this trinomial in form by cosecant to the 11 of 2 theta and then of course times cosecant of 2 theta cotangent of 2 theta d theta. Okay? Let me copy this part because I always write this. So we now have distribution of cosecant to the 11th inside, getting cosecant to the 15th of 2 theta minus 2 times cosecant to the 13th of 2 theta plus cosecant of 2 theta, and this is raised to what? To the 11th, no? So raised to the 11. So multiply by this. Okay? Can you follow, guys?
Yes
Guys,
po, sir.
so what
Yes,
is
sir.
our u here? Cosecant in its term. Cosecant of 2 theta. What is du, guys? Guys, what's the du? Guys, Gonzalez, what's the du? Negative, derivative of 2 theta is 2. Then cosecant of 2 theta, cotangent of 2 theta, d theta. Okay, guys? So we now have u to the n, you put negative 2 to be du. Then same thing here, u to the n, you put negative 2 to be du. And for the last one, u to the n, put again negative 2 for this to be du. Okay, so each is a general power formula. So I can now get integral of cosecant to the 15th 2 theta. I can make that as u to the 15th minus 2 times u to the 13th and then plus u to the 11th. For this case, better to replace it by u so that you won't write not many characters, no? So, and then times what? What is cosecant 2 theta cotangent 2 theta d theta? That is du over negative 2. Over negative 2. Guys, I do not know if there are still people I am talking to. I don't understand why math is like a COVID to you. But I understand, because not all of us really good in everything. Like me, I do not want, of course, English. When I was in college, I do not want English. Even in high school. I admire people who are very good in English communication. Okay, guys? Guys.
Yes, sir.
Okay, so let's now integrate every term. What's the integral? Guys, what's the integral? Maglunsod. That is very simple. That is already actually our formula. U to the 15th du. What's the integral? Maglunsod. Sekretaryo.
U to the 16, sir, over 16.
What about the next term? But don't forget to multiply
Minus.
by 1/2, ha?
Yes, sir.
1/2 times negative 1/2 times negative 2. That is now 1, no? So we just have u to the,
U to the 14 over 14.
okay, next, minus 1/2 times,
Times U to the 12 over 12.
okay, good. Then plus c, no? Okay, so we now multiply negative 1/2 times 1 over 16. That is 1 over 32. Then u, what is u? Cosecant, no? And that is raised to 16. So times, cosecant to the 16th of 2 theta. Okay, guys? Plus 1 over 14 cosecant of 2 theta raised to, this cosecant is raised to 14, minus 1 over 24, then cosecant to the 12 of 2 theta, and then of course plus c. Any question with that, guys? Guys, any question with this? Guys, before I
Wala
move
po,
to the
sir.
next slide. Okay, no
Wala po.
question. Okay. Okay, so let's have number 3. Okay, be ready, Serrano, ha? Integral of e to the 4w and then cotangent to the 7th of e to the 4w, then cosecant of e to the 4w, and this is raised to, this cosecant is raised to, let's say, 5. Then dw. Okay, guys? What's the exponent of cotangent? 7. And it is a combination of powers of cotangent and cosecant. Cosecant is raised to 5, so it means it is not case 4, no? So we have no choice but use case 5 only here. E to the 4w should be what? Should be placed together with dw because that is what? A part of the differential of e to the 4w. Okay? So we have integral of cotangent to the 7 of e to the 4w, then cosecant to the 5th of e to the 4w times e to the 4w. Okay, guys? So we're going to form a quadratic cotangent then raised to 3, making it 6. And we have to get from cotangent to the 7, one linear, together with one cosecant from cosecant to the 5th. And then associate it with e to the 4w dw. So here we'll have just cosecant to the 4th of e to the 4w, and then times e to the 4w, then cosecant of e to the 4w, cotangent of e to the 4w. Okay, guys? Do you have question with that, guys? dw pa. So we still need dw here. Let me copy this because I'm going to write this again. So this is now equal to integral of. So what are we going to transform, Serrano? Serrano. Onera. Nepomuceno. Absent. I'll put here absent. Onera absent.
Sir,
Serrano. Okay, what is to be transformed?
yung cotangent square e to the 4w.
So cotangent is squared. That is read as squared, not square. Okay?
Opo, okay po.
Cotangent is squared. So that is equal to what? So this is to be transformed. What's your name, Iho?
Onera po.
Okay, so that is equal to
Cosecant squared e to the
cosecant
4w
squared e to the 4w
raised to 3.
minus 1 quantity cubed, no? Or raised to 3. Then cosecant to the 4th retained. Later, we're going to distribute that in the expansion of this. No? Then copy. I'll just copy this, the one that I saved. Okay? So that is equal to Galang. What's the expansion, Galang? Galang. Escareces. Domingo. Cosecant what? Cosecant to the 6 cube the first. Am I right, guys? Minus 3 times the square of the first times the second plus 3 times the first times the square of the second minus the cube of the second. So that's the expansion. You should know how to expand that mentally, huh? Okay, guys? Guys. So what is our u, guys? Or what is our u? Then we are going to distribute later. Do I need to distribute now? So I think better to have our u immediately. So to save time of writing many characters. What is our u, guys? Cosecant of e to the 4w. What is our du? Almadrigo, Alcantara, mga absent. Daming absent ngayon. Absent. Chuapoco, absent. Pag not complete attendance, walang magandang additional points sa final period. Nagbibigay pa naman ako ng additional points na malaki pag final period complete attendance. Peñaranda, Navas, absent also. Gonzales, absent also. What's the derivative? Negative. Derivative of e to the 4w is 4 e to the 4w, then cosecant of e to the 4w, cotangent e to the 4w, dw. Okay, guys? So cosecant is what? That is you distribute. This is u to the 10th because cosecant is u minus 3 u to the 4 plus 4, 8 plus 3 times. This is u squared. This is u to the 6. U to the what? U squared, u to the 4th, I mean. So u to the 6 minus, this is u to the 4th times negative 1. So negative u to the 4th. Oh, see the pattern turn 8, 6, 4. So these numbers will serve as n later. We have different n values and same base, u. Then what is cosecant e to the 4th cotangent e to the 4th times e to the 4th w e to the 4 w dw? That is negative du over 4 or du over negative 4. Okay, guys? Okay, guys. Negative 1/4 is not needed. Put it out. U to the n du. U to the n du. So u to the n plus 1. I think I can have it here. I have much space here. Negative 1/4 integral of u to the 10th minus 3 u to the 8th plus 3 u to the 6 minus u to the 4th, then du, no? Yan. So, for the first integral, Reyes, absent also. Reyes, absent. I am jotting this here. Reyes, absent. Rialin, absent. Ponciano.
Sir,
Oh, what's the integral?
u to the 11 over 11 po.
U to the 11 over 11. Then, negative, negative, positive, 3/4.
U to the 9 over 9 po.
Then, minus now, no? Where I'm minus, negative 1/4, 3 minus 3/4. U to the,
7 over 7 po.
and then negative, negative,
Positive po.
positive 1/4 times
U to the 5th over 5 po.
u to the 5th over 5 plus c. Okay? Finally, we have negative 1 over 44 cosecant to the 11th of e to the 4w plus 3 over 4 times 1 over 9. So that is now 1 over 12. Am I correct? 3 is cancelled out with a factor 3 from 9. So there's a remaining 3 times 4, 12. Cosecant to the 9th of e to the 4w minus 3 over 28. 4 times 7 is 20. Cosecant of what? To the 7th of e to the 4w plus 1 over 20. 1 over 20 cosecant of e to the 4w quantity to the, so that cosecant is raised to 5, no? Then plus c. Could you please check my answer? If I miss something, did I copy everything correctly and replace u by its proper value or equivalent, guys? The one is replying, so I assume that is correct. Okay, guys? Guys. Okay, number 4. We have integral of tangent. Tangent um, to the ninth of, let's say, beta secant to the square root. Let's have it square root. It's square root of secant of beta d beta. Okay, guys? So here m is what? M here is 9. So this is case what? Case 5. So I'm going to form a quadratic tangent raised to 4 to complete the tangent to the 8, then plus 1 tangent that we're going to segregate that gives us a total of 9. And then we get from secant beta 1 secant also. So what's the remaining after getting 1 secant? See, that is secant to the 1/2. If I get 1 from here, so that is secant to the negative 1/2. Secant to the negative 1/2, because I got from it 1 secant, so that is secant to the first of beta, then 1 tangent from tangent to the 9. Okay, guys? Guys. So this is what we're going to transform. Transform that into guys, so what's the transformation? Secant squared beta minus 1 raised to 4 and multiplied by secant beta raised to negative 1/2 times secant beta tangent beta d beta. Okay, guys? Now, if you want, you can immediately have it in terms of u. So in terms of u, we have u is what? Secant of beta, and then du is what? Du is secant beta tangent beta d beta. So this is it. So we can have it u squared minus 1 raised to 4. This is secant beta is u to the negative 1/2, so that you can easily understand the expansion in simpler form. And this is du, exactly the du of this, no? So expansion gives us integral of this u to the 8. So u to the 8, meaning you have to raise the first term to 4th power minus 4 raised to the third. That is u to the 6 times the second plus 6 u to the, so that is how to expand 1 3 3 1 by Pascal's triangle. 1 4 6 4 1. These are the coefficients. As the power of u squared decreases, the power of negative 1 increases, no? Or if you want, if you take it 1, alternate sign. Okay? Positive, negative. 6u to the, yeah, so square now, to the 4th times the square of 1. So that is 1 minus now of 4u. So u squared times raised to 3. So then the last one raised to 4. The second, sorry, multiply to u to the negative 1/2. Okay, guys? So let's now distribute 8 plus negative 1/2. That is what? 3.5, giving 7 halves. Am I correct, guys? Huh? Is it 7 halves? Conti? Domingo? Ay, wala na akong kausap. 4. So 5.5. What is 5.5? Guys, I think it's not 7. It's not 8 minus, it's not, this is wrong. 8 minus 1/2 is 7.5. That is 13.5, I think. 15.5. 7.5. What is that? 7.5, 7.
15 over 2, sir.
15 over
15
2 po.
over 2.
15 over 2, sir.
Yan, nabuhay sila. Alam nila fractions. 6 minus 1/2 is 5.5. That is 11 over 5, no? Am I correct? 11 over 2. Plus 6. U to the, this is 3.5. Ayan ang 7 halves. Minus 4. U to the 1.5. 3 halves. Then finally, u to the negative 1/2. Then du. Okay, guys? So we now have may pattern. 5 minus 4, 11 minus 4, 7 minus 4, 3 minus 4, negative 1. So the first term we have u, and u to the plus 2 over 2, 17 over 2. Okay, guys? Over 17 over 2. Then minus 4 times u to the 13 over 2 over 13 over 2 plus 6 times plus 2 over 2 u to the 9 over 2, then over 9 over 2 minus 4 times u to the 5 over 2 over 5 over 2 plus u to the 1/2 over 1/2, then plus c. Okay, guys? Guys, what is this equal to? 2 over 17. Then what is u? Secant, no? Secant, then to the 17 over 2 of beta minus 8 over 13. Secant to the 13 over 2 of beta plus 12 over 9. But 12 over 9, there is a common factor from the numerator and denominator. So 12 over 9 divided by 3, 12 divided by 3, 4, 9 divided by 3, 3. 4/3, no? Secant to the 9 over 2 of beta, and then minus 8 over 5, then secant of beta, this has a exponent of 5 over 2. Oh, wait a minute. Let me write exponent first. And then finally, we have 2, then secant to the 1/2, or that is actually square root, no? Then plus c. C. Señores, señoras, ¿entendéis, señoritas, señoritos? Children, guys. Do you still have questions about this? Because we are now going to move to the last case. And then you'll have now quiz tomorrow. Or you want it on Monday? Or so that you have much time to study. Monday. Okay, you don't want to talk? I will be respecting your... So we have case 6. Okay, 6 now, guys. Guys, you are now on case 6. What is under case 6, guys? If the integral has the form, we have actually under case 6, 3 subcases or 3 formulas. So case 6 involves product of sine and or cosine functions. Case 6, product of sine and or cosine functions. Okay, guys? I will respect your silence. You do not really want to talk. So in final period, you cannot talk to me also. I'm not going to entertain any questions of yours. So the following are the formulas, guys. Number 1, if you have this combination, integral of, let's say, sine of mu cosine of nu du, where u is a function, assume it is differentiable, of course, m and n are constants. So this is equal to 1/2. So actually, this 1/2 times the identity of this, no? 1/2 of, what's the identity of sine times cosine? Product of sine and cosine, what's the identity? How to convert this product into sum? Product to sum identities. We have sine of the first minus sine of this argument minus this argument. So that is m minus n u plus sine of m plus n times u. M plus n is multiplied to u. The whole thing is argument. Same thing here. Then everything multiplied by du. So that's the first formula. The second one, we have integral of cosine of mu cosine of nu. if you have product of cosine and cosine of similar angles or argument, so we have 1/2 integral of cosine of m minus n u plus cosine of m plus n times u. Then everything multiplied by du. So this is the third one. What about if we have this combination? Sine of mu cosine of, sine of, so sine of nu du. So this is equal to 1/2 integral of sine of m minus u, m minus n rather. M minus n of then times u minus, and it is supposed to pag sine cosine also. Cosine of m minus n times u minus cosine of m plus n times u quantity du. Okay, that's it. So these are the three formulas that you have to be familiar with. I did not place any more combination of cosine times sine because cosine times sine you can interchange and have this form. Is that clear, guys?
Yes, sir.
Okay, so let's apply this. So let's say we're asked to evaluate. Number 1, we have integral of sine of 7x cosine of 10x dx. This is equal to 1/2. So this takes the form of number 1. Okay, guys? So we now have then 1/2, then sine of sine cosine, you get the difference between 7x and 10x. So that is 7x minus 10x. Okay? So that is, my m here is 7, my n is 10. 7 minus 10, that is actually -3. Then my u is x. Okay, guys? So we now have plus sine of, take the sum. 7x plus 10x. Quantity dx. But you have to take note of this identity. Take note. So let me write it here. Let's move this a little. I want you to take note of this identity. That if you have sine of negative theta, that is negative sine theta. This identity, very useful, because this will lead to negative argument. So how to get rid of the negative sign out inside. And if I have cosine of negative theta, you do not have to worry about the negative. You can discard that and have it cosine of positive. That will be useful together with this. So we now have negative 1/2 integral of, so this is sine of 3x now. Sine negative 3x, sine negative 3x negative sine 3x. then dx plus 1/2 integral of, so this is sine of, what's the sum? 17, no? 17x, then dx. Okay, guys? Guys, so I'm going to put what? Let me adjust this here because I won't have enough space. So I'm going to put positive 3 balanced by 1/3. So negative 1/2 times 1/3 because I'm planning to put inside 3. Ayan. Plus 1/2. I'm planning to put inside 17 with a dx so that I now have 17 sine of 17x times 17 dx. Okay, guys? What's now the integral? Guys, what's the integral? Guys? Guys? Anyone? I'll be calling the one who is talking here. Panciano? Is Panciano around or absent? Absent? Daming absent ngayon. So integral of sine u du is negative. It's now positive, 1/6 cosine of 3x. So integral of sine u du is negative 1/34 cosine of 17x plus c. Yeah, that's it. Number 2. Guys, nabahas. Peñaranda. What if I have sine of 4 ln x cosine of, let's have sine. Sine of 2 ln x dx all over x. Okay, guys? This is equal to, so 1/2. What's the identity for sine? Guys? ln x differential is dx over x. So this x goes with the dx. So sine of sum or cosine of sum. Pag sine, cosine, no? Let's have difference. 4 minus 2. That is 2 ln x minus cosine of, what's the sum? 6 ln x. Okay, guys? Then dx over x. So this gives us 1/2 integral of cosine of 2 ln x times dx over x. And then minus 1/2 times the integral of cosine of 6 ln x times, I will put enough space here because I'm going to put or introduce a constant. So cosine u, for this to be du, I need 2 balanced by 1/2. For this to be du, cosine u, for this to be du, I have to multiply by 6. Cosine u, du now. But I have to balance by 1 over 6. Giving 1/4, what is the integral of cosine? Integral of cosine u du, sine u. Minus 1 over 12, integral of cosine u du. Again, that is sine of u. Do you have any question, guys? So again, this takes the form of number 3. This number 3. Is that clear, guys? Guys?
Yes po, sir.
Okay, let's now have, you are answering if the answer is just okay. It's not okay not to be okay. Integral of number 3 plus integral of cosine of 3, then hyperbolic tangent of 2x cosine of 9 hyperbolic tangent of 2x dx all over, that's a long fraction. Oops. Then we have hyperbolic cosine squared of 2x. Okay, guys? Guys, first, let's apply identity for cosine. 1/2 integral of, pag cosine is still cosine, no? Cosine of difference. 3 minus 9, negative 6. Hyperbolic tangent of 2x. Plus, that's plus if you have cosine, plus cosine of, take the sum, 12. 12 hyperbolic tangent of 2x times dx over hyperbolic cosecant squared 2x. When you bring it up, secant is hyperbolic secant is squared. Okay, guys? So the derivative of hyperbolic tangent is hyperbolic secant squared. So no problem with this anymore. No? Just fix the constant later. But cosine of negative angle, negative 6 hyperbolic tangent of 2x, that is equal to cosine of positive 6 hyperbolic tangent 2x. Remember, cosine of negative theta is cosine of positive. So I can discard this negative, getting 1/2. Then integral of, I need space here because I'm going to put positive 6 later. Cosine of 6 hyperbolic tangent of 2x times hyperbolic secant squared 2x dx. Okay, guys? Guys, wala na akong kausap. It's so sad. I'm very sad. Cosine of 12 hyperbolic tangent of 2x times hyperbolic secant squared 2x dx. What am I going to put here? Put 6 times 2. So getting 12. What's the derivative of hyperbolic tangent? Positive or negative? The first three, positive hyperbolic sine, hyperbolic cosine, hyperbolic tangent, they are all positive, the derivative. Hyperbolic cotangent, hyperbolic secant, hyperbolic cosecant, they are all negative. They are derivatives. Is that clear, guys? Wala.
Yes, sir.
Yan, sumagot. Mag-lunch sila. I will put 1/12 here. So what about here? 12 times 2, 24. Balanced by 1/24. Okay. Ready now to evaluate the integral. Ready now to integrate. So we now have 1/24. Integral of cosine, positive sign. Then copy the argument. Okay? Then plus 1/48 sine of 12 hyperbolic tangent of 2x. Okay, guys? Guys.
Opo, sir.
Okay, number 4. So integral of so let's have E, or let's have sine. Sine is square root of log to the base 2 of x. Cos sine also. Sine of is square root of log of x to the base 2 dx over, let's have this fraction, and over x. Okay, guys? So this is a combination of sine. By the way, I think I missed something. X is square root of log of x to the base 2. Okay, guys? Let's check if this will work. So I will apply identity for sine. So that is 1/2. So integral copy. Sine of, let me put here, I think I missed something. Wait a minute. There must be coefficient. Ungroup. Oh, here I will make it just put it here. Okay. And this is supposed to be 7. Okay. Oh, sine. So what's the difference? So the identity for that is cosine, no? So this is 1/2 cosine of, get the difference, negative 6 square root of log to the base 2 of x minus, get the sum, cosine of 8 square root of log of x to the base 2. Quantity. The remaining will serve later as what? As the differential, no? Part of the differential of argument here. So to the base 2. Okay? I don't think I have much space. I have to move this. Let's copy everything and move to the next slide so that I have much space. So this is equal to 1/2. Guys, what is cosine of negative? Again, cosine of negative theta,
Positive po.
positive. Cosine of positive theta. So I can discard this, no? Integral of cosine of 6, no? 6 square root of log of x to the base 2 times. So I have to have here dx over x square root of log to the base 2 of x. What's the derivative of this? Let's check. And then actually similar here. The only difference constants. Then we have here minus 1/2 integral of cosine of 8, no? So we have 8 square root of log of x to the base 2, then times dx over x log of x to the base 2, square root of that. Okay, guys? Well, let's have substitution. Let u be equal to, for each, you will have log, no? And then I will just have later 6. For the first one, actually 6. No? Let's have separate. U equals, but you can have u just the log if you want. And then you fix later the 6. Let u be equal to 6 square root of log of x to the base 2. What's the derivative? And just multiply by dx to be differential. 6 over 6 derivative. That is 1 over what? Let's have 6. Let's take the derivative. 6 times, I will put it in front. 1 over, the derivative of this is 1 over x ln 2 times 1 over 2, that is for the square root. 2 is square root of log of x to the base 2. Okay, guys? This is supposed to be in the numerator, this part. But I can have it multiplier to this quantity. They are just the same. Okay? Okay, then multiply by dx. Am I correct, guys? For the other one, my u is 8 square root of log of x to the base 2. And then du, let's have du1. Similar, no? 8 times. I will just copy everything. Copy B. Copy here. Why there's no over? It's all right. Easier to fix. So I can now have here 1. Okay. And this is equal to what, guys? 3 dx over yan, 2x. Ay, no more 2, no? Because 6 divided by 2, 3. ln 2 times square root, no? Square root of log of x to the base 2 times ln 2. Similar here, this is equal to 4 dx over square root of log of x to the base 2, then ln 2 here. Okay, guys? So that's for the du of the second integral. Okay. Finally, we now have 1/2. What is this, guys? I will put 3 over ln 2 here. I balance outside by ln 2 over 3, no?
Yes,
And this is the cosine u. What's the integral of cosine u? Sine u. I'll do it mentally, ha? 6 square root of, I introduce mentally, log of x to the base 2. Then plus negative 1/2. What will I put here? 4 over ln 2. So balance by ln 2 over 4. Then integral of cosine. It is now cosine u du after putting, no? The integral is sine of u. 8 square root of log of x to the base 2. Okay, plus c. Oh, that's it. Then all we have to do is just simplify the answer. Okay, guys? Do you have any question with this, guys? Sorry. Control Z. Guys, do you still have question? Guys?
Wala po, sir.
None,
What's
sir.
now the simplified form? We will now have quizzes. These are the things that you're going to do. 1 ln 2 over 6 sine of 6 square root of log of x to the base 2 minus 1 ln 2 also over 8 sine of 8 square root of log of x to the base 2 plus what? Plus c. Okay, guys? Oh, guys? Are there still have questions?
None, sir.
Okay, so that's it. If you don't have questions anymore, just so it's already time. So that's for today. So if in case you have questions that you can't ask at this point in time, you just PM me. Is that clear, guys?
Yes,
Yes po, sir.
Yes,
Okay,
sir.
bye. It's already time.
Thank you po, sir.
Don't